All right. Welcome, everyone, here and online. This is a very special edition of our Trends in AI.
We're live.
Right? Yeah, we're live. It's really cool. I was really looking forward to actually sitting with people to chat. So, as usual, I think we should start with a bit of an introduction from each of us. We have a special guest today, and we're at a new place at CODAM. So we're gonna say a word about that. So, Jakub, why don't you start?
So I'm really excited to be here live at CODAM. I think AI is the future of coding. We'll talk a little bit more about that. Yeah, I've been in AI for like the last 30 years. At the stage where Marzieh did finish her PhD, I dropped out, started a company. Haven't regretted it, and still in love with AI, and things are going really fast, and yeah, every month we are amazed by all the new stuff.
Olivier?
Yeah, so Olivier. So I'm a PhD student at the University of Amsterdam. I work on forecasting-related problems, and I'm part of the Air Lab, which is a lab founded and in cooperation with ALT. Yeah, working on problems of thinking about how can we predict, forecast stuff more efficiently, better at the scale of Albert and Bol.
I'm Marzieh. I'm responsible for the research that we do at Zeta Alpha, and I think we have been doing these webinars for 2 years now, almost, and this is the first time we are doing it in person, and it feels really special. So thanks everyone for being here as well.
Cool, and finally, I'm Sergi Castella. I'm an analyst at Zeta Alpha. I try to read up on what's happening in the world of machine learning and AI, which is pretty crazy these days. And yeah, we try to make some sense out of it, right, as part of our product and our content initiatives. That said, I think that we should just jump right in. I don't know if we have time. We have so much to cover, right? So we should just go right ahead. First, a couple words about this stage, right?
Yeah, thanks CODAM for hosting this, and also thanks to Kickstart AI and AIgents who are kind of co-hosting it here with us. Yeah, it's part of the World AI Week. Who knew that it was World AI Week this week? Yes, a few. So yeah, it's been a lot of events in Amsterdam, especially the World Summit AI was in Zaandam. Gabriel and I were there yesterday and day before yesterday. 3,000 people from all over the world came to Amsterdam to talk about AI. It was a lot of talking, not so much like technical stuff, very businessy. So now we're going to dive deep and kind of report from the trenches of the research. But before we do that, what do you see here?
Yeah, you see here visualization that we work on this stuff, and we have generated this using a bunch of modern techniques like language models, and actually this using GPT-3 to generate automatic clustering of papers. And we do some sort of ranking, use different signals like what's popular on Twitter, what's getting citations, who are popular authors, and we are working on this type of visualizations to help make sense of a very large landscape of papers.
Yeah, so these are all the research papers of last 4 weeks, or roughly, right?
Yeah, last month, more or less, yeah.
All right, but before we dive deep into the research, let's talk a bit about the news. Who has their own GPU? Or, yeah, so what type of GPU do you have to run models? RTX 6000. Oh, nice. Yeah, so...
yes, the first story is this Nvidia announced new GPUs, which I guess are like the engine of modern machine learning.
Did anyone get one? I think they were sold out in like 2 minutes.
It went on sale day before yesterday, I think.
Yeah, 2 days ago. Yeah,
it was sold out in a few minutes, indeed.
Yeah,
so it's not really available yet. It costs 1,500 euros or something like that. But it's 2 to 4 times faster than the previous generation.
And secondly, we have these one transformers, which is I would say pretty mysterious company still, Adept AI, is this small startup that is doing AI research, and they have a bunch of high-profile researchers, right? A lot of from the original Transformer papers, and they announced this model that is able to perform actions specified in natural language in kind of any computer program, which is a bit of a very fuzzy thing, and they still didn't give any details.
It's a pre-recorded demo.
Yeah, it's a pre-recorded demo. I mean, looks like a very cool application, but we have to the jury's out in whether that's actually gonna be, you know.
So for now, they put the flag down that we have something, but they haven't released it yet. So we are waiting to validate.
But they do have Ashish Vaswani on the team, so that's certainly something to brag about. In other news, so at World Summit AI, there was a big panel on autonomous lethal weapons. And it was discussed that it's reassuring that some of the largest robot makers actually kind of put out this declaration that, like Boston Dynamics, you guys probably have seen this sort of robot dog and the walking humanoid robot. And Boston Dynamics and 5 others have declared that they would not weaponize their technology. Do you guys believe that?
I think they mostly produce for DARPA, right?
Right. Boston Dynamics was started by DARPA, yeah. But now they're owned by Hyundai, I think. Yeah. Oh. But I just did a sort of short diggings on Twitter, and it seems like the weapons industry thinks something completely different. Witness these pictures, so I think we're not out of the woods yet there. So what else is in the news?
Yeah, so we have this AlphaTensor release from DeepMind that was quite popular, in which they train an agent as they basically frame the problem of finding optimal matrix multiplication algorithms as a single player game, and they find new optimal algorithms for multiplying matrices. And it's kind of interesting because you would think that problem is a solved thing, but it's not really. It's kind of still, I would say, a question whether that has real implication in terms of efficiency, because a lot of it is kind of more theoretical. But it's still a kind of interesting implication. And a lot of people thought that DeepMind was only focusing on games, and it's interesting that they're now actually using that expertise into other domains and how that's.
And they again have an article in Nature.
Yeah,
so the
an
link
article
is here,
in Nature,
which I think is their main business metric. DeepMind exists to produce articles in Nature.
It's super relevant, right? I mean, matrix multiplication is the bread and
butter
at the
core of everything.
Everything, so.
Yeah. And it is actually faster. I didn't read the entire paper, but it's substantially faster than the state of the art.
Yeah, but it's only, I think, on specific choices of 3x3 matrices.
Yeah, exactly.
Not a generic.
Yeah. But it's
but it's still, I mean, it's
finds new kind of symbolic ways to compute multiplications, to have to do less multiplications to multiply multiple matrices, which is very interesting. A lot of theoretical computer science people are very interested in these type of things.
And in kind of related, going back to GPUs. In fact, the still coming GPU from Nvidia, the H100, has its tensor cores also optimized by deep reinforcement learning, especially for performance on transformers. So that's why it's going to be even much faster. So I think AI is the future of coding as well. There's this, obviously, you guys have probably heard about CodeGeex, right, from OpenAI. You can kind of specify high-level description of code. It generates the code for you. I think it's available now in
it's a paid product, and I think it's free if you're a student, right?
And there's a lot of competition coming up for that, also from the Chinese, CodeGeex.
So this new open source language that is on GitHub, you can just go and check it out. With 13 billion parameters, and I think it's really good that there's competition in this space, right? It probably will make the products better and the cost of running them for the user lower. So I think that's all positive.
Has anyone used CodeGeex here?
I played around a little bit with it, but not really used it extensively.
I'd be interested to learn like what is actually the quality in sort of in real life, what people get from it.
It's pretty good, I think.
The demos look awesome.
And I think everybody's kind of scared to become dependent on it because I just noticed this one, that Hugging Face is also launching their new Big Code project. So no longer big science, but big money maybe, I don't know, in collaboration with ServiceNow. And what's interesting is that this Chinese one, the CodeGeex, was actually not trained on Nvidia. It was trained on Huawei hardware, 900 Huawei GPUs. So I guess that's because the White House is also trying to stir things up in AI and made access to Nvidia cards kind of impossible in China.
Yeah, no, it's super interesting to see how, like, as AI becomes more relevant and more useful, it becomes like more of a geopolitical weapon of like these things that you're saying, like the expertise on chip manufacturing and who gets access to the chips that power off these models, and suddenly governments are interested in getting their influence in that as well.
And I guess in Europe, we make our mark on AI mainly by regulating it. The European AI Act is the horseman of the apocalypse for AI innovation, something, but the US government couldn't stay behind and have just proposed their own AI Bill of Rights. So the European initiative is being followed. And last one here is Tesla AI Day. It was quite the media event. Did you guys watch it?
I saw some highlights.
Yeah, I saw the robot. And
honestly, I've always been disappointed by how clumsy a lot of these demo of humanoid robots are. It's like, it doesn't look all that great to me.
I expect by now the technology be a bit better than that.
Boston Dynamics is slightly better. They had the dancing video, but not for Tesla. I think Tesla more and more well known for the tweets of Elon Musk than for its AI. Also since Karpathy left, maybe, I don't know. What other news? All right, here, local, meanwhile in Amsterdam. So with Lab 42, have you guys heard about it? It's the new AI hub in Science Park, Watergraafsmeer here in Amsterdam. About 500 people are in the building, all concentrated working in AI. So it's a very large critical mass. The EKI labs, you're there as well, right?
Yeah.
We have moved there. All the AI students, the Informatics Institute, LLC, it was opened end of September. So our next edition of this show is actually going to be live from Lab 42.
And finally, we had a small workshop at Science Park that was really, really cool, also in person, about a bit more than a month ago, right? Or a month ago, actually. There was like already the third edition of Transformers at work. I should totally sign up for next time. And a bunch of interesting, very important conferences happening and coming up, like iClear, Calling, and that we are also indexing on our platform.
Yeah, so iClear papers are live in Zeta Alpha since a few days, 4,900 anonymous papers still, but you can actually use Zeta Alpha pretty well to de-anonymize them because we we have also the archive version, and Calling is coming later today, so it's ongoing right now in Korea.
They were randomizing the substitution or the submission number, right? So it's not 5,000 submissions, or is it already 5,000 submissions?
It's 4,900 unique papers.
Oh, wow.
Okay. Yeah, I'm happy I'm not a reviewer. Are you reviewing for iClear? Six papers.
Yeah.
All right. Yeah.
But actually, I did use our platform to find relevant ones to bid on them, because you have to do the bidding. So that was
smart.
Yeah.
So World Summit AI was not such a tech-heavy, R&D-heavy conference, mostly business types, but there was some good stuff. One of my highlights was Jay Alamar from Cohere. He did a very nice tutorial presentation on large language models. And this was kind of the essential slide that kind of captures a lot of what's going on in AI R&D at this moment. So you have these very large language models, and a lot of AI research these days is really what kind of text do I give to make them do something special. Time series forecasting, prompt engineering, exactly. Yeah. So prompt engineering is the new programming. Do you do prompt engineering?
No, not yet, but I guess there will be like jobs like for prompt engineer
exactly.
shortly. Yeah.
PhD in prompt engineering.
I just want to say, like, I think that this also, I agree that this is very much gonna be super relevant. Something that I'm super excited about, language models being so prevalent, and kind of the unification of like everyone is using transformers, is I think that this is gonna enable like even further kind of optimizations on the hardware level. As like you said before, Nvidia now is optimizing tensor for specific architectures of neural networks, and that will make these kind of even cheaper and faster and more efficient to run large models.
So yeah, as I said, a lot of research these days is actually about finding some magic prompt. This is an example paper that came out late September. Ask Me Anything, simple strategy for prompting language models. So basically, it's about evaluating whether a particular claim is true given a preceding text or context. Something like John and his friends went to the theater and saw Jurassic Park. The claim is John went to the park, which is not true because he went to the theater. But it's kind of hard for language models to answer that question correctly. So in this paper, they just like engineer GPT-3 to come up with a better formulated context. And yeah, basically their performance goes up by a lot. And this is very typical for modern papers.
It's so interesting. It feels like there's so much low-hanging fruit in this space, right? There's a lot of papers that come up with pretty simple ideas. We're gonna see one later that just like work great, and it's just like pretty simple, basic ideas.
And a lot of actually, a lot of the work in AI has become kind of yeah, a bit obsolete because this paper came out also end of September about new summarization. And there's been a ton of people working on summarization models, like very special summarization models for decades. And now you can just do zero-shot summarization. You give the text and you say to GPT-3, summarize the article in 2 sentences, and it does that. And this paper actually did kind of a human judgment study where it turns out that people prefer the summaries done by GPT-3 without any training on summarization over summaries constructed by specialized summarizing models. Marzieh, you worked on machine translation. Is that already the case in machine translation?
I do like to think that the progress in these fields, like the summarization before large language models, machine translation, that led to having large language models, the progress in transformers. So it wasn't fully obsolete, but yeah, you have to also embrace new powerful models and move with them.
So we kind of dug in a little bit for this. Do you guys know the State of AI report? It's like a yearly overview of the complete field. Research, business, investment, talent, geopolitics, regulation, everything. It's a great thing to read. And we got contacted by the authors, Nathan Ben Eyck and his team, to help them out with some questions, because in Zeta Alpha, we have all these research papers, and basically a lot of trends, like identifying new developments, is about analyzing the core of the research papers. And some of these things, like, you know, how many times the word, I don't know, AlphaFold or transformer is mentioned in these documents, that's kind of easy using search engines, but others are much harder. So we actually kind of took these questions and started playing with these prompt engineering, and basically kind of almost got it to work to a point where we can take a bunch of research questions, like from the State of AI report, like how many publications are there per country and per affiliation, how are particular GPUs being used. Some of these are easy to answer, but if you ask a question like, what are transformers applied to? Well, it's, everybody knows they started in NLP, right?
Yeah.
But
like the lines are very fuzzy, right? In classifying that, and like you cannot just do counts.
they went into computer vision, but does it?
You cannot.
Yeah, is it called computer vision or object detection or classification? So we did this kind of going from the question to the particular fields that you need to do these kind of analyses. And we built prompts for that. And some of the research in State of the AI is now generated by this kind of prompt engineering from research papers. So for example, we ask what country and what affiliation the author has. Usually it's Britain, but there's some variation. So this is still fairly easy to do using classical methods. So United States is still on top, but China is growing very fast. I don't know how that will remain if the Nvidia GPUs dry up, but I think they're on a roll. And this is actually the question about the transformers. So you did a little bit of an analysis into this, right?
It's super interesting to see how, I mean, like we said, transformers started only with text, but very, very quickly they're taking over other modalities, which, and we're seeing this kind of unification of, there's like new papers coming out like every month saying, hey, we just used the vanilla transformer or some version of that into this modality and we made it work. And I think that's, yeah, it's kind of exciting. In a way, it's exciting to kind of, it's exciting that architectures are getting boring because now suddenly people are paying more attention to other parts like the data, right? The optimization techniques that are used. And that's kind of a whole new area of interesting things popping up.
Transformers are taking over the world. Another thing, going back to GPUs, is basically you can ask the question like, what hardware is used in this research, and just tabulate it. And well, the results are not really surprising.
No. I mean, I would just urge you to look at the
log
scale. It's log scale. So
yeah.
just
so
it's very much. I mean, the 16,000 versus 700.
You know how many was it actually mentioned what they used?
Less than half. So not every paper, you know. There are also theoretical papers, right? They don't use anything, but
I still think it's pretty high.
Yeah, and I just want to say, like, I heard this point made that I think it's very important to understand why this happens. Is a lot of the problems why these new kind of challengers of hardware don't become mainstream is because it's not that much that the hardware is not fast or not good enough. They're probably much better than Nvidia, but there's a whole bunch of software stack that goes into.
CODAM.
Yeah, exactly.
Software. It's only software. Like all these startups think it's about hardware, but it's about software.
CUDA is so kind of mature as a framework, right, for doing high performance computing, and then all of these other challengers don't have that, and then it's like really hard to build that from scratch. So you need like maybe a decade of people building on top of that. So it's definitely gonna take a long time for any of these challengers to challenge Nvidia.
Yeah, you see that even Google with its TPUs is having a really hard time. Actually, you see that there were less papers mentioning TPUs in this year than last year. And
so the hardware, like the performance difference needs to be way bigger before people will start. Like if it's 10%, then you're not going to bother. But if it's like it's 10 times as fast, then it starts interesting. But I get most of these hardware startups, by the time they get their software right, then their hardware is already like maybe as fast as Nvidia's, and then it's like, why would you bother learning some new tool?
Yeah, and there's pretty decent frameworks these days for scaling up Nvidia GPUs across very large clusters. So yeah. So these are some of the smaller hardware vendors: GraphCore, Habana, Sambanova, Cerebras. And you see that actually only GraphCore is still really growing. We looked a little bit deeper, both at the TPU papers and the GraphCore papers. And actually, the majority of papers mentioning GraphCore are authored by people from GraphCore. So that's good. At least they're using their own stuff. The majority of papers using TPU are authored by Google. So
I'm surprised these companies don't reach out more often. Like I literally, like Nvidia sometimes reaches out to us or like to colleagues, like, I don't know, can we sort of help you, or do you need systems or whatever? Which makes sense, because then you start using their product and then you'll keep using it if you go to a company. Yeah, it would make sense if these companies would do that too.
Nvidia's lead is not challenged in any meaningful way yet, I would say. I think I checked yesterday, Nvidia was like the 6th company by valuation on the US, or it was crazy high. So I guess that's kind of
right. So maybe GraphCore can export more to China now that Nvidia is banned. I think they're not banned. Last but interestingly, we looked in this State of the AI report with this prompt engineering method, slice the papers by China and US, and then look at what kind of actual application they are working on. And interestingly, the Chinese authors work much more on computer vision, on video and multimodal, and I have some idea why, but maybe that's insinuating a little bit. All right, so you can do interesting analytics. The report came just out this week. It's a great read. It's 110 slides, so we recommend. You had one additional favorite from the report.
I quite like this slide, which shows how after DeepMind published their AlphaFold and AlphaFold 2, a lot of other initiatives from smaller companies teamed up, smaller institutions like universities and companies teamed up to build similar models. And I think there's a trend that you've seen also in the space of like CodeGeex, for instance, or like DALL-E, where a private company, big company makes something, and then like the community picks it up and makes it open source and improves on that.
Yeah, there was a similar slide for large language models, exactly. Right? With the Bloom from Hugging Face.
And quickly mention of this. Of course, we have also a paper about this later, but text-to-image generation has been so popular, and it's been one of the things that has captured the attention of the public related to AI, I would say the most this past year. And it's related to the diffusion model, which is a new exciting modeling technique that is also being used in protein folding and other applications. And that's certainly a space that we should watch for the next year.
Stable diffusion. Do they mention?
Yeah, I'm pretty sure they in the bottom.
Stable diffusion was the hit of September, I think, or when did it come out? Everybody was playing with it.
1 month ago or something. Everyone was talking about it.
The main difference there was that, in contrast to AlphaFold, it was released open source right away. So everybody picked it up. You can play with it on Hugging Face.
The speed of iteration of these things is crazy. Like you had the first model, and I was like, "Wow, this is super impressive." And then within a week, 3 other competitors or open source do like the same thing or even better. And then I was surprised by the steep curve of progress of this, and also then.
And then immediately to video.
Yeah, I thought, oh, that's probably going to take another year, and then 1 month or something.
Yeah, and the next iteration of this is in the past month, Meta and Google released their first kind of text-to-video generation, and I feel like we have the papers there later to comment quickly on that. But it's kind of interesting what you're saying, the speed of iteration on this. Meta published their paper one day, and then a week after Google had their paper out. I mean, of course, they had been working on that for a long time, right? But it's kind of interesting. And if you see, this is part of a publication on iClear, and if you see the publications on iClear, a lot of people are working on this problem. So it's definitely something that is.
I remember at our Transformers workshop, we asked the panel their prediction for the next 12 months, and they said, video generation. It's 4 weeks now, so.
So as a disclaimer, this is very much infancy. These videos are more like GIFs, moving images rather than videos.
Yeah, they're really short clips, right? Yeah. All right, what else? More state of the art. Read the report. We need to dive into. One thing that I really like is that they make these very specific predictions on what will happen in the next 12 months. So video generation is not on there because they already seen it before the report came out. A couple of other interesting ones. What is your favorite one, Marzieh, from these?
How accurate are they? I don't remember last year. What did they predict?
They scored about 50% correct on their predictions. So which one would you like to see come true?
Yeah, that's a good question. I would go with the third one, actually, because that's just like language models are something that I'm really a fan of. And
language model trained on 10 times more data. Yeah.
Even more, yeah.
It would be interesting if the last one, I mean, it's not sort of an AI thing, but it will lead to a lot of practical problems if kind of this stuff will happen in the future a lot, where you're not allowed to sort of train on, I don't know, Reddit or some other things, and you have to think about who generated this data and who do I need to, yeah.
That will complicate life more than the European AI Act, absolutely, yeah.
So something I think is, I mean, it's not really here, but something that I think is interesting is a lot of people were expected GPT-4 to be released by now, right? Because actually GPT-3 is already 2.5 years old, which in the timescale of how long it took OpenAI to release these models is quite large. So I'm wondering if that has any implication on like what you guys think that's gonna look like, because I don't know, like what kind of like thing is gonna focus on.
I'm waiting for Palm to be released. I think it's very promising.
Yeah, that was announced but not released. Yeah. I think that they maybe got a bit scared. Meta released their chatbot, and then there was a lot of media backslash because it started seeing a lot of.
It will have to come from startups. So one that I believe in is number 5. So GAFAM stands for Google, Amazon, Facebook, Apple, and Microsoft, going to invest in AGI companies. And there's not a real mention in the prediction who that would be, but if you were sleuthing online, you couldn't help missing this one. Actually, Sundar Pichai from Google mentioned Hugging Face in one of his keynotes. So that's my prediction. I would put my money on that. I'm not an investor in Hugging Face, unfortunately. All right, let's dive into the paper. So we are Zeta Alpha. We collect and organize these papers in our platform. We think it's the smartest way to discover and organize knowledge for AI and data science people, but we complement it with curation that Sergi is doing. It's a whole lot to say about the platform. Try it out. And it basically helps us to organize the yield of the month in papers and kind of look at signals like Twitter mention, GitHub code, other measures of impact. And Sergi, how do you pick the 10 most promising ones?
Yeah, I mean, part of it is just I pick the ones that I like. So there's a bunch of subjectivity going into that.
Human in the loop.
Yeah, certainly. There's a lot of it is also like with the signals that you just mentioned. Like you cannot, unfortunately, you cannot look at signals like citations that are, of course, kind of the gold standard for impact, because when a paper is just published, it doesn't have citations. But you can look at other like more popularity signals, like you said, on code implementations, how much traction that's getting. Twitter, a lot of people use Twitter for that. So that's a little bit how we create this editorial selection of papers. Yeah, and that said, I think we can just jump into the first one, which is about prompting. Yeah, again, like we always include papers on prompting, but I think it's definitely like a super interesting space and a lot of interesting developments there. I think Marzieh can speak a little bit more in detail about this paper called Faithful Reasoning Using Large Language Models. Yeah, so what do you find? Well, can you maybe give an overview of what this paper investigates and why is it interesting?
Yeah, sure. So this is an interesting one from DeepMind. So what they are, the question that they're asking is that these large language models, they are at the end of the day a black box when we do inference. And when they generate something, we don't know how much of it or which part of it was generated because of the prior that the model had, how much of it depends on the context that the model had. And the idea here is that to make it more, to make the inference step more interpretable and traceable. And they do that in an interesting way that can also be applied to like the prompting that when we talked about earlier, so basically how they do this is they have this selection cycle and inference cycle. And the idea is that the selection part would select parts of the context that are relevant to generate the output. And they do that like in an extractive way so that the model doesn't hallucinate at this stage, so not really generating anything. And then the inference step looks at what was selected instead of looking at the question or at the input, and then tries to find the answer or yeah, whatever the task is to work on. And then this is like a loop, and they do that until they are, well, it depends. Like you can have like multi-step reasoning, or you can also do that until you found the answer rather than printing unknown. And so it is an interesting one because what they essentially do is instead of manually coming up with prompts to prompt these language models, they do it in an algorithmic way, an automatic way. So they take out the subjectivity of the person doing that, and like that's one side of it, and it also adds the interpretability to the output. So I think both of them is something that's important and lacking when we work with large language models. How do you?
No, so I just wanted to ask you, like, do you think that, of course, like this method of kind of advanced prompting and kind of more interactive, where there's not just like a static prompt and then a generation, like it improves certainly on the interpretability of the output because you can see all of these steps. But do you think that this is good enough to kind of make these models deployable in you know, situations where you want them to be trustworthy and all of this, or do you think that a complete different paradigm is needed, or that just, you know, machine learning altogether is not suitable for those tasks, I guess, where there's kind of like input needs, like the output needs to be you know, properly precise or interpretable?
Yeah, I think personally, I think it's like a step in the right direction. So like defining the logical steps of how you come up with a conclusion. So it like how you go from statement A to statement B to statement C, defining that, and then being able to like physically trace that and show in the model in the context where it comes from. That's a lot more than you can already ask for in terms of like where the output comes from and whether the quality is good enough. Because so what they also wanted to do in this work was not really look at the question, just look at the extractions, the selections that they do. And you might think that it might limit the knowledge that you have at your inference time. So the quality might still not be as good as it can be. And that's something that you can still work on. But I think it is, to me, sounds like a good direction of adding interpretability to inference.
Question is how much truthfulness do you need to get trust, right? Like something like 80% truthfulness, is it enough to get trust? With most people it isn't, right? You wouldn't go into a car or an airplane, which is 80% trustworthy.
I would say that an interesting thing, I mean, in favor of this is like trust is not only about how precise model is, right? It's also about it fails. When it fails in understandable ways, right? Like when humans fail, kind of, it often you understand why they failed, right? It was like, oh, they had this problem in their reasoning or something. So I feel like, and these papers, I feel, let you understand a little bit or peek into where, in what step of the reasoning a model might fail. So I think that's a kind of, as you were saying.
Yeah, it's very much like very trying to model how us as human beings also, like given a context, we try to to reason and come to the conclusion. So like the cycle of doing this still can be like something to work on to get to that 100%. But I think that's it's a step in the right direction.
We'll have more papers along those lines of thought. So this is a very different one.
Yeah, very different one. It's also
open source.
So actually, it was
the
open
first
source.
Open source from OpenAI in a long time.
Exactly. This paper was really popular a couple of weeks ago from OpenAI. And they properly open sourced it, and it's public. You can go on you can download it from the Hugging Face hub. And basically, what I would like to highlight. So it's a transcription model. You give it audio and it outputs text.
And it's really unsupervised, right?
Yeah, exactly. So what I find most interesting is that like a lot of this open work from OpenAI is very predictable in the sense that they are often using relatively simple modeling techniques, right? So like here, they're just using a vanilla transformer. And what they excel at is kind of to collect the best data set in this domain and then use that to train a model. And again, like the kind of strongest their strongest kind of point that they're trying to push for is this idea that they're training on data that they're crawling from the web. And given that this is a general kind of data pre-training, it's not a special data set, they can generalize to a bunch of benchmarks. Because what had happened in the past with a lot of initiatives in the transcription space is that people will reach superhuman performance on a certain benchmark and then realize that then when they deploy this in another setting, humans are still much more trustworthy. So this paper tries to solve that by training on dataset agnostic, and
language agnostic, right?
It's multilingual, but it doesn't have every language.
Oh, it doesn't do languages that it wasn't trained on?
No.
Okay.
So I tested the Persian, it wasn't generating anything, but
really?
Spanish it did, yeah.
That's too bad.
It was good.
So the big thing is always accents. We use Otter to transcribe our interviews.
Yeah, that's
well, yeah.
If you have somebody with a really strong accent, it makes up a lot of things. So we'll try this one on the next interview.
But you didn't get your GPT this year, but you did get Whisper. So
no. Totally. No, it's good that they're working on other initiatives beside that.
So check out Whisper from OpenAI. We talked a little bit about.
Yeah, we already talked a little bit about this. This is the paper from Meta about their video generation. And like I said, the thing that I would like to highlight from this is like it does seem a little bit misleading to call it text to video, because when you hear video, you expect something a little bit long and more of something that has something resembling a narrative, right? To it or something. What?
It's more like a meme.
Yeah, exactly. This is more like a meme or a GIF, or like, because the actually when you look at the modeling that they use is kind of closer to doing a text to image and then image to moving image kind of modeling. So I feel like the proper text to video, where you kind of describe a scene and then you generate a scene, that's still seems very challenging, and that's the. I mean, I don't want to make predictions about how long it's going to take, but...
About 3 weeks.
But it feels really similar, like when the first autoencoders came out and you had these really tiny pictures, right, of these faces were pixelated and stuff, and everybody was also like, this doesn't look that good yet. So it really feels like a first direction, short video, not that high quality yet, and now it's just, better quality, more pixels, and a longer sequence,
And when you look, I mean, when you think about it, DALL-E 1 was also released 1 year before DALL-E 2, and the difference between those two models is it's insane, like how much better, right? They got in a year. So you totally expect this to become much better in the next year.
And especially because you see across like all these papers and models, you see that like scaling matters. So if you just scale, it becomes better. So it's relatively, I wouldn't say easy. I mean, it's still super hard, but like the sort of the first step to take is makes sense to like simply scale it up, use more data, use a bigger model.
And it's an arms race, right? Because not 1 week after Meta came out with their thing, Google had to
Google
do the
came
same.
up with a pretty similar approach, although it's a bit different.
The architecture is different?
Yeah, the architecture is a little bit different. Google has this kind of cascade of, like Google relies more on doing a bunch of super resolution steps where they generate the first image. You can see there it's 16 by 40 by 24, and it's 3 frames per second. And then they do spatial and spatial and temporal super resolution, which means that they kind of interpolate more frames, and then they make higher resolution versions of that. And diffusion models are very good at this kind of like progressive kind of refinement of images. Yeah. So that's the.
From what I saw, the quality of this looks better than the Meta one.
A little bit
it's a very high
better.
resolution. And
yeah.
But it will not become open, I think.
I don't think it would be. And yeah, this next one, I mean, we're a search company, so this is a slightly, I would say, more niche.
It's in our own ballpark.
Yeah, but I still like to highlight some information retrieval papers every month because they're, I mean, very close to our heart. And I know Marzieh does research on this with us and probably has something to say about this. So what did you think about Promptagator? I heard that it made a lot of noise in the kind of information retrieval community. I don't know how much because it was from Google and like of course they have a big speaker like megaphone, or whether the technique has a lot of merit. What do you think?
Well, I think definitely former, but also like the technique is also really nice, and I'm saying that because also we did. You
can say that.
Let's be a little bit more proud about that.
Yeah, we did publish a couple of months ago something very similar to what they are doing here. They did cite us, so that's nice. So the idea, the technique is that how we can use these large language models to generate the data that we require and don't have to train a model. So in this particular work, they look at it as, so you can think of like, you have different data sets for retrieval, different domains, different sizes of data, everything. And you can do domain adaptation on the document, but and that solves some of the problems. But another aspect that you can focus on is the query itself, and that is like whether you have any good queries or not, and good is whether the queries answer the intent of the document that you look for that particular data set or not. So in a data set, for instance, good queries are like really short phrases. In another data set, long questions need to be answered. And you might not have that in a lot of cases. And in this work, they generate these queries based on the data sets that they want to later on train on and evaluate on by coming up with specific prompts for that data set. And they do it with 8 examples, like 8 samples from the data set to then generate, I think, 1 million queries per document.
It's also a much higher scale than
so
what you did.
There are some differences. This work with our work, the main idea is very similar, but in terms of generation and also evaluation, so they do it on the retrieval task. But it's a nice example of how we can use large language models to solve some of the problems on the data side, not necessarily on the models.
License to print any amount of synthetic data that you need, right? It works pretty well.
Yeah, exactly.
I'm still curious though. You guys got it to work very well on re-ranking, but not so much on dense retrieval. What's their core of their trick? Is it just scaling?
I think scaling is very important. I think another thing that they do is that, so they come up with prompts that are specific to that data set. So that is something that, so we had one prompt that would use for, across all data sets. And so the evaluation is like zero shot on beer benchmark that is like multiple data sets on different domains. So if your prompts are specifics for the data sets, then the types of queries that you generate it fits the intent of that data set. So I think that's something that we are missing as well.
So still need to get the professional education on prompt engineering a little bit better. Right, this is not about prompt engineering, but it's a very exciting paper.
Yeah, this
is the rest of the AI. The rest of AI was not working on transformers, it's working on diffusion models these days.
Yeah, diffusion models and protein folding. I mean, AlphaFold, and I have some friends working on biology, and they hear the buzz, and like a lot of people are actually trying to start. I mean, I feel like a lot of people are trying to figure out what these things are useful for. It's not like they're instantly useful for a lot of research, but they're picking up ways to use these things. But I wanted to highlight this paper because it uses diffusion to do protein folding, which is figuring out the structure of very large proteins. And they do some interesting modeling techniques, like they just use a clever representation space in which they have some invariances that are useful for the problem at hand. And I feel like this is pretty common in papers where like physicists are the authors, or like the mind behind that, because the physicists are always thinking about invariances. Yeah, so the other reason I wanted to highlight this is the new research. This comes out from a collaboration between Stanford and the new research lab from Microsoft, led by Max Welling here in Amsterdam. And
42, but the building next to us.
Yeah, the building next to us. And I'm quite excited to have that kind of research initiative also in Amsterdam. And I think it's a really positive thing that a lot of very interesting research is going to come out of that lab. So
moving into the pharma industry, whoever thought. But,
so this is just one
nowadays everything runs on Linux in Microsoft, so it's safe. By the way, if you haven't looked into diffusion models yet, this is the growth curve of diffusion models. So they're basically being applied, doubling every year, and being applied to just about everything. Olivier, you work a lot in like time series prediction.
It's not that much. Yeah, some papers being published, but it's it's the same. It's all the hype. I actually had a couple of students who wanted to work on applying these diffusion models to time series modeling. I mean, it makes total sense. But it's also a bit like all the hype, like similar that you had last year was about graphs, and then the year before about transformers, and the year before about guns. So usually it needs some time to kind of find out what this model or technique is best for. And then I think we're now like in the peak that everybody's trying it out for every task, which makes sense. And then probably in the next 2 years, we'll get a better understanding of what are the best tasks for these methods.
I think usually also with these models that once at the beginning when they come out, everyone is really impressed with what they can do, and it takes some time for everyone to look into what they can't do and where they fail. So I think it's a valid like direction for research to explore that.
All right, a few more papers. We have to cycle through them quickly, I think. We have a couple more minutes. So just a shout out then. I'm not really an expert in robotics, but I think this is a really big breakthrough in robotics from Sergey Levine and his group. They basically built a foundational model for robots. So there's a single robot controller which works mostly on vision, and it does kind of motion planning for generalizes to new types of robots. So they trained it on a mix of different sensors from different robots and different actuators, and then it generalizes to a new robot, even to a quadcopter drone, while being only trained on robots that are like on the ground. So I thought it was pretty impressive. And one more robot paper, talking to robots. So this is very cool. There's a website where you can watch videos how the robot behaves. And you can actually give voice instructions, kind of thing with speech recognition and text and planning and everything. You can say things like, move the blue cube to the bottom left corner, or make a smiley out of all the faces and put the green stars as the eyes. Yeah, maybe it's a bit cherry-picked, but they did release their data set, and it's available for further research. One paper which kind of goes back to Marzieh's point about truthfulness from large language models, very different approach. So if you give this prompt, no matter how well you engineer the prompt, two baseballs X and Y are released from rest at the same height. X is heavier than Y. A lot of people think the heavier ball will fall faster. It's kind of common sense physics, but it's not true. Even using tricks like chain of thought, yeah, you can get it to form some explanation, but it still gets it said wrong. So what they did here in this very nice paper from Google Brain Team is they actually wired up a physics simulator. So they translate the original problem into a set of instructions for a MuJoCo physics simulator. And then, yeah, the model sees that the balls drop at the same speed and then gives the correct answer. So it's a little bit like the models that look up stuff on Google, or right, or have a calculator. I think Palm or Lambda had a calculator.
It's kind of increasing the inductive bias of the model in some ways, you could say it.
Yeah.
It's so interesting that I just remember in the event we had a month ago, we asked Thomas Kipp from Google, who's doing research on computer vision, what he was kind of excited about in terms of benchmarking computer vision models and visual understanding. And he mentioned this whole idea of interacting with the world, and this kind of having models that understand what happens when you tweak certain parts of a scene and how it's gonna evolve. And I feel like this paper kind of is in the same vein of including this physics simulation into the training recipe of a large language model, so that it gets these intuitions about the physics of the world.
Yeah, but the difference is huge. If you look at how the sort of the dark pink one, how that scales, it's just twice as good as the model without this augmentation. So definitely a single sort of pass-forward language model is not the only recipe for reasoning. Then just very quick shout out for Meta. Also, we thought all the deep learning work on games came out of DeepMind or OpenAI. Meta also making their mark with a big advance in these collaborative games. I don't know, does anyone play Diplomacy or Hanabi?
Yeah, well, it's been a while, but actually when I actually graduated on reinforcement learning more than 10 years ago, and then I used to play Diplomacy now and then with friends, and then some of them said, this is never going to happen, like any AI is never going to do it. And I was like, I think like a reinforcement learning based thing will probably do this in, I think I said like 20 years, so I was still a bit optimistic.
You're only one order of magnitude off,
yeah.
No, not even, yeah.
But yeah, I mean, it's pretty impressive because it's really hard to make reinforcement learning work, and especially for problem settings that increase. So here you have multiple players, so the dimension of the problem is just insanely big. So that's what to me of this work is what is impressive about it.
I like Noam Brown's Twitter handle. It has something to do with this combinatorial explosion, I think. Paper came out just earlier this week. I haven't read it yet, but I thought it was noteworthy to mention it. A few more last bits of GitHub.
Yeah, a couple of highlights of releases from Meta. Released this framework for accelerating machine learning into like very heterogeneous hardware, which I think is interesting in this space of like, is Nvidia gonna be dethroned from the king, which I think would be a really good news in terms of like competition. And then this Google open sourcing a black box optimization framework.
I heard that here at CODAM, everybody has to code everything in C or C++ from scratch, so no AI template.
Yeah, and a bunch of other repositories that are gaining a lot of traction, like the Whisper, that is neural radiance fields, which we haven't talked about, but we highlight often using neural networks for rendering. Motion diffusion model, like diffusion models also for other motion planning tasks, and yeah, stable diffusion, like we said. And a couple of other releases from DeepMind and Meta AI, very important for the progress of AI benchmarks, data sets. It's all about that.
This has nothing to do with GitHub.
Not
but,
really, right?
it's one of the most talked about papers on Twitter this month. I'm not sure I don't think we can cover it in the remaining -1 minute. But check out Git rebasing. It's a revolutionary idea of combining multiple models. So okay, that's it.
That brings us to the end of our Trends in AI. Thank you everyone for attending here in person or online, or if you're watching this on YouTube later on. It's a lot of fun. I don't know what you guys, any closing remarks you want to say?
First time live, a milestone. So next month we're gonna have it in Lab 42. So do come over to visit. It's a very nice community there. And the next one after that is gonna be from Europe in New Orleans.
Live from New Orleans?
Yeah.
Yeah, going to Europe, yeah.
Yeah, so with some music in the background, maybe.
Hopefully, yeah.
All right.
All right, so thank you very much for your attention, and I'll see you in the next one.
And if you can't wait, try Zeta Alpha to discover your own trends in your own area. Thanks.
Thank you.